The sun is a hot ball of gas that generates enough energy in just 1 hour to easily meet the energy needs of planet Earth for an entire year. The challenge is how to harness all of that energy. So the problem that man faces is not a lack of energy, it's a lack of ways to capture the existing energy from the sun and efficiently convert it into usable energy that can heat our homes and provide electricity. So I guess you could argue that we don't have an energy problem here on Earth, we have a conversion problem. In this lesson, we will take a look at some of the technology man has developed to capture what the sun has to offer. Now, solar energy is energy obtained from the sun. So if you think about the sun's rays, you will notice that they are spread out. In order to use the energy from the sun, we need ways to collect and absorb solar energy. For this, we use solar collectors. And you may not realize it, but you are probably using solar collectors every day. For example, there's a good chance that calculator laying on your desk is run by solar energy. Small devices like calculators require only a few watts of power, and they can generate this power without the need of batteries using just a few photovoltaic solar cells. These small cells are often referred to as simply photovoltaic cells or solar cells, and they are devices that directly convert light from the sun into electricity. So as long as there is light, these little cells seem to power your calculator forever. And you can recall the term photovoltaic by remembering that the word photo refers to light, and the word volt is a unit of electric potential. Therefore, a photovoltaic cell converts light to electricity. If photovoltaic cells are connected together, you have a solar panel. You have likely seen solar panels on rooftops of homes or businesses, but they can also exist as large arrays on open fields and can even be found powering satellites out in space. Photovoltaic cells use thin layers of a semiconducting material called silicon. Now, silicon is an element, and you can find it on the periodic table along with all of the other elements. It is also what makes up sand. When light particles hit the photovoltaic cells in the solar panel, electrons in the silicon atom dislodge and bounce around, which starts a chain reaction. These electrons dislodge and move, one after another, in a continuous flow, providing an electric current that can be used to power homes and workplaces. Now we learned that photovoltaic cells directly convert the sun's light into electricity. So what happens when the sun is not shining? Well, unfortunately, when there's no light, solar panels cannot generate electricity. Therefore, some type of battery or backup energy system is needed to use this energy at night or during cloudy days. We also use solar thermal energy to collect solar energy. Solar thermal technology creates electricity indirectly, as opposed to photovoltaic technology that directly creates electricity from light. Solar thermal energy collects the sun's light, which heats a fluid, such as water. The resulting steam is used to run a generator that makes electricity. You can recall this term by remembering that the word thermal refers to heat. And essentially, solar thermal energy works as a giant water heater. And this form of solar technology is primarily found in very warm places where the sun is reliable. Solar thermal plants are capable of creating massive amounts of energy. These power plants often use parabolic troughs, which are the solar thermal collectors used to collect the sun's radiation. These parabolic troughs are shaped somewhat like a half-pipe that you see skateboarders use and are lined with mirrors. These mirrors focus sunlight onto a focal point where the fluid can be heated until it becomes steam. This steam then spins a turbine for electricity generation. Like photovoltaic solar cells, solar thermal electricity generation can only occur when the sun is shining. Therefore, a type of thermal energy storage is required that allows heat energy to be collected and stored for later use. With solar thermal energy systems, high-pressure liquid storage tanks can be used to allow plants to store hours of potential electricity. Let's review. Solar energy, which is energy obtained from the sun, is plentiful. However, in order for this resource to be used, it must be captured and converted to heat or electricity. Photovoltaic solar cells are devices that directly convert light from the sun into electricity. If photovoltaic cells are connected together, you have a solar panel. When light particles hit the silicon atoms within the solar panel, the electrons get dislodged and flow in a continuous pattern to provide an electric current. Solar thermal energy works like a giant water heater to create electricity indirectly. Solar thermal energy collects the sun's light, which heats a fluid such as water. The resulting steam is used to run a generator that creates electricity. Solar thermal electric generation may use parabolic troughs, which are solar thermal collectors used to collect the sun's radiation. One major drawback to solar energy is the fact that the sun does not shine consistently. Therefore, a type of thermal energy storage is required that allows heat energy to be collected and stored for later use.